So welcome to this week's episode of Leaders on a Mission, where I'm joined by inspiring leaders driven by the impact of creating a healthy and sustainable world. Now, in today's episode, it's a real privilege. I'm joined by Karim Englemark Cassimjee, CEO and co-founder of EnginZyme. They're a Swedish biotech company really looking to disrupt the chemicals industry with a unique approach to self-biomanufacturing. And I met Karim earlier this year in Paris at an event and cornered him until he kind of committed to kind of come on the show. So Karim, listen, thanks so much for living your promise and coming on the show. It's great to have you on today.
Thank you, Simon. It's great to be here. So thanks for inviting me.
My pleasure, Karim. So maybe we'll just start with I suppose just getting an understanding, or I suppose looking at where you are now, looking back, what have been the main forces, I suppose, that have helped shape kind of, I suppose, your business trajectory, as it were.
Well, I'm a scientist by training, so I have a PhD in biotechnology, and doing science, I always was struck by we do great things and then we write a paper, if you want to simplify reality, and then that's where sort of it ends. We increase the knowledge, but we don't really, it's very far from reaching the real world. So for me, it was really important to get stuff, make it real, get it out in the real world. And I'm very passionate about sustainability, and my skill is chemistry and biotechnology. So for me, it's almost like an obligation to see what I can do. I'll do my part, and I invented a way to make chemistry greener. So I just want to roll with that. And founding a company was natural once I had that conclusion.
Yeah, no, great. Because some people, when they get that sense early, it's about writing papers and I want to get more commercial and get stuff out there in the world. They might tend to move away from some of the academia, as it were. Were you kind of tempted at that point, or because some of the research you did would have taken years, right?
Yeah, but it's more about it's partly forming a company and being an entrepreneur is cool and fun, and seeing if you can make money is also fun. But the underlying for me is I look at how chemistry is done, and chemistry is a $5 trillion market, or euros if you wish, or pounds. And it's everything we do. It's in our clothes, it's in the food we eat, it's the color on our walls, and just seeing how all these products are made in a non-sustainable way was just frustrating to me when I knew that enzymes can do it better, sustainable, and cheaper if you get it right. So that was sort of the nerdy drive behind, like, this is wrong, let's change it.
Yeah, absolutely. But with that, was there always a burning desire and ambition, do you think, to be a CEO as well?
Actually, no. I grew into that, and now I love my job, but that wasn't my sort of starting point. I was like, okay, I have this invention, it's patented now, that's great, let's start a company. Oh, wait a minute, who's going to be CEO? Well, okay, I am. It was like, that's really what happened. I'm like, I had my one of my co-founders like, hey man, can't you be CEO? He's like, no man, you're the CEO. Okay, I'm the CEO, whatever.
I was going to say, how do you, like, when you look at that with your co-founder, right, and you're both really kind of deep at the bench and the research and both PhDs and postdocs, and at that point, how are you making that that decision, as it were?
Yeah, actually, my Samuel Haggestam, he's not a chemist. He's a serial entrepreneur, really super skilled person. I'm so happy to be worked with him. But he was from the philosophy side from the beginning, and then he started to working with the artificial intelligence, software, data, and he didn't know the chemical space. So his argument was basically, the space, this is your invention, you be the CEO. And I said, okay, I'll be the CEO, but then you're going to have to teach me all this stuff about how to build a company. And that's where we started. So I think we were lucky that we were blue-eyed enough at that point. You know what I mean?
Yeah, absolutely. And I know this is a really broad question because this was 10 years ago.
Yeah.
Next year will be the 10th anniversary, right? The company when you.
Yeah. So the company was formed in 2014. So yeah, that's right.
Yeah, and no doubt there's been a huge amount of learning along the way, right? And we'll come back to that in a bit. But what a little bit about the journey. But what comes to mind for you if you look at yourself now, right? And you look at the CEO, co-founder back in March 2014. As a CEO, what have been the major lessons, do you think, or the major learnings or changes that you've had to go through in that?
Yeah, I'm going to say something that I think many people say, but it still is so true that coming out of academia, you underestimate the value of commercialization and the difficulties involved in commercializing new technology, and that's difficult, especially when you're hitting it in a conservative market as the chemical industry. So getting customer traction early and understanding what is actually customer traction. It's not someone saying, "Oh, impressive technology," and then you think, "Oh, they like my technology." It's actually very bad if they say impressive technology and then that's where it ends, because that just means they think it's good science. They don't want to buy anything. So understanding that you have to solve actual needs of customers. And this is so cliche, but still having solutions for actual problems and not coming out with a solution looking for a problem. That's what it boils down to, essentially.
Yeah, absolutely. Which is interesting, right? Because I suppose if you look at the industry and you look at Symbio, and there has always been that tendency, isn't there? When you look at it, we've got some interesting technology. It does wonderful things. And I think more recently, people now have been much more critical looking at product fits, looking at the unmet need and the economic viability of that, as it were, right? So, how do you make that transition then?
Yeah, and I think what you just said translates also into, selling your product or technology in some way, not only generating revenue, but doing it with good unit economics. And everybody's talking about that these days, that you need to have viable business from day one, essentially. So what I have to say about that is we don't believe in green premiums. I try to avoid that. Many companies do sell, but they sell to a niche market for a specified thing where green premium is accepted, and they can't go anywhere from there. They're stuck. And yeah, I think when it comes down to, transforming something really huge and making people change their habits, you might be able to make them pay a little bit more, but probably not, So you need to sell something that is attractive at a reasonable cost. And that means that the demand is on us to produce green chemicals at required cost. And that's, serving more. I live in the south part of Stockholm with a bunch of hipsters around me, and they'll go and buy, the most expensive thing because it's green, but that's very few people, so.
Yeah. Has that changed much then when you think about your business model and your approach, the green premium and the lack of it out there in the market, as it were? Has that had to evolve and change due to, I suppose, the economic situations and changes out there? Or is that always?
I wouldn't describe it as a change. I would describe it more as a static. If you manage to get a product out that is actually green, then people will make a big deal about it being green. But if it's not a good cost, then you will not even hear about it. There's nobody bragging, or very few people bragging about their green premium products that they're buying. Except for at consumer level, you might see that. But with B2B, difficult.
That's the challenge, isn't it? Because your markets are B2B, right? You're not selling to the consumer, as it were. And
right. So so we're supplying the chemical manufacturing industry with manufacturing solutions. So we design manufacturing processes based on enzymes, and we reformulate the enzymes to function as a catalyst, as a product they're used to. So we can implement that in standard chemical equipment. And I think that is really important for us, because that means that we can really operate as a classical chemicals company, a partner they're used to. I think that's also a key here, that asking people to completely change and revolutionize the industry well, if you are to do that, congratulations, I will support you. But I think it's much easier to evolve than the industry. Chemical industry has already gone through so many changes and has done enormous amounts of work to become greener and succeeding. So it's not strange for a chemical company to strive for greener products, because greener products in chemistry means less waste, less energy, and more bio-based inputs. And the two first things I said, less energy and less waste, translates to less cost if it's successful. So it's a win-win. They're actually getting more bang for their buck, and also green if you succeed with this in the way I think it should be done.
Amazing. So tell me a little bit about EnginZyme then, and I suppose just the challenges that the company solve.
So in nature, enzymes are the catalysts in our bodies and cells and everywhere that transform starting materials to products. When human beings try to do the same thing in the chemical industry or in a chemical factory, we end up using heavy metal catalysts, usually high temperature, high pressure, lots of energy, fossil-based inputs, because that's what we know how to do. And those catalysts are, and to do this transformation, you need a chemical catalyst, as I said, and those are expensive. So you need to make them work for prolonged periods of time. So you put them on a porous material, for example, and put it in a chemical reactor and use it for months or even years. So to make it simple, EnginZyme does the exact same thing, but we take enzymes, nature's catalysts, put them into porous materials, and make them work for months. So we once it reaches that point, it's just classical chemistry after that. Here's a catalyst. And if you ask me what catalyst is, oh, it's an enzyme. Oh, okay, but it's a powder. Yeah, exactly. Now go use it. So we sell the catalyst. We also devise, as I said, full manufacturing processes, so we can license those. And in the future, when it makes sense, we will also invest capex in building plants to produce end products.
Okay.
And that's how we aim to serve the industry. And it really answers to the need of the industry to make greener products, but again, at cost, a good cost.
Yeah. Okay. So you're not replacing, you're replacing the fossil fuel, because most of these products, right, they come from a fossil fuel origin. Is that the point?
Yeah. So people pull stuff out of the ground and they use that for everything, for driving cars, for making plastic, for everything. And that's the source of the raw material that goes into the lion's share of chemical processes. So that, of course, needs to change. We need to learn how to use stuff like sugar, vegetable oil, things like that instead of these fossil-based, so that you can have bioplastic and you can have biomaterials and everything else. And enzymes are evolved to work on bio-based materials. They can work on fossil-based as well. But if you want to use a bio-based material and transform it into something else, you have a good shot in using an enzyme doing that.
Yeah. So essentially, you might take a sugar, for instance, or a vegetable oil, you'll apply your particular enzyme, and then there'll be a catalytic kind of reaction, and then you'll get certain kind of molecules that will go into, footwear or certain different applications.
Yeah, exactly. And it can become the building blocks for polymer plastics. It can become a bio-based surfactant, essentially soap they use for washing everything we see. It can be used for paint coatings. Like I said, there's no single moment in your life that you're not touching the chemical industry in some way. I guarantee you that. In fact, your body, the nitrogen in your body, 40% of it roughly comes from the Haber-Bosch process, and that goes into that goes into fertilizer and then the food we eat. So we're actually we couldn't sustain the amount of people we have on Earth without the Haber-Bosch process. It's mind-boggling. So chemistry is everything, right? So it's a huge challenge we have now to transform the way we make the stuff we use, essentially. So of course, it's important to find bio-based fuels and everything else, but people sometimes outside of our space forget, what about the color on my wall? What about my t-shirt?
Absolutely. Tell me a little bit about the novelty of your company, right, and what you do. It's more about am I right? It's more about the self-free manufacturing, the way that you go around doing it. Is that the the IP and the genius around the idea, is it?
Yeah, exactly. So what we do is called enzyme immobilization. That's putting an enzyme on a solid support material, like I explained. That in itself is not new at all. It's been done since the 50s, but only very few enzymes have been formulated that way successfully. There's a very short list of large-scale industry processes that use immobilized enzymes, because it's difficult to keep the enzyme happy, to make it work and for a long time, as I mentioned. So the beauty of our invention, my invention that I did in 2014, that has now been refined and now working exceptionally well, is that it's general. We can take any enzyme type and do it and immobilize it. And then we can mimic nature by using several enzymes in sequence. So if you take your example, starting with sugar, one enzyme will not turn it into something valuable that you need. You probably need 3, 4, maybe 6, maybe 10 enzymes. You need to make all of those work like an orchestra and keep them happy and active. So you transform this sugar stepwise into your final product that could be a building block for plastic or something else.
Yeah, great.
So and it's also important to emphasize that we don't just immobilize enzymes. We do the whole thing. We do from farm to fork. We supply a manufacturing process that includes the purification of the product. So we can start by saying we can make the enzyme, we can engineer it to be stable, we'll mobilize it, we'll put it in a chemical reactor and make sure that you have a good chemical reaction that is efficient, then we'll scale it up. And all this in the company is also supported by the use of artificial intelligence, data management, automation, so we can be fast. So we need to compete with other players in the chemical industry. And if they can do a process in somewhere between 1 and 3 years, and it takes us 10 years, well, people are not going to buy our stuff. So we need to do it in the same time or shorter. And now we actually can do that.
Amazing. So tell me, thank you for that. So where about are you on the journey then? You know, it's coming up for 10 years. Maybe just outline a couple of, I suppose, key milestones really when you think about it.
So we went through a few changes and pivots. In the beginning, we set out to sell the material that I invented to mobilize enzymes. We wanted to sell that to people who already have enzymes. There was no real market fit for that, because the people selling enzymes didn't want to change the business model because of some company in Sweden that just got started. And the people buying enzymes are buying it from people who don't want to mobilize them. And so it's just a market block there. We couldn't really get through that. So we then changed and started to build internal capabilities of running the reactions, actually using the enzymes and optimizing those for customers and partners. And in that process, we realized, well, we need to do actually more. We need to do the whole process and do the full manufacturing. So the company you see now basically is formed in 2019, and we raised Series A in 2020, actually on Friday, the 13th of March, 2020. So Friday the 13th is my favorite date these days. And
13th of March.
Yeah, it was the day before the stock market just crashed.
Yeah. That's my birthday, by the way, so it's a good day.
Oh, congratulations. You see,
Yeah.
what a great day that was. So, and then, making a long story shorter, we raised Series B just before Christmas, which was fantastic. We had a lot of, the industry, the synbio industry had a few setbacks. A few of the leaders in the field were unsuccessful in the stock market, or where their tech was disproven. So we were happy to raise that Series B just before Christmas. And I remember my kids asking me, "Dad, are we gonna celebrate Christmas?" I was like, "Yeah, maybe." But then we did, and we finished that race. So now we're here, and now the target now is to succeed with something that many companies in our field fail, and that is scaling your technology. So we are, I don't want to say too much, but it looks really, really good right now. We're managing to deliver on ton scale pretty soon. So I'm really happy about that. And now it's all about commercialization, revenue, proving the business model in different aspects, setting us up to become a self-sustaining company, which I think, if you believe the word on the street of the capital market being a slaughterhouse or etc., That is what's needed. Good unit economics, decent revenue. And I want to see a direct line between what we do now towards the end goal, the vision of the company. So making sure that what we sell is actually not some diversion or some sidetrack or something. We need to sell what proves that our vision is actually sane, where we can go. We're starting out in the food market. So we have food oil process happening. That's multi-ton of our catalyst. That's billions of tons of product, actually. So it's enormous process. And we also have a smaller pharma product, which is actually just kilos. But that's so we're quite diverse in where we apply our technology. And again, that's to prove that we are not just an enzyme company. We're so much more. We're a manufacturing, chemicals manufacturing provider of processes for chemicals manufacturing.
Absolutely. No, thank you for that. Lots to unpack with that. But I think the technology can do an awful lot, many different applications. What's the process to then deciding and choosing where you're going to really focus and spend your kind of...
Yeah, that's an excellent question, and one that we ask ourselves almost daily. What do we do if we have this enormous amount of applications that we can attack? What do we do now, and what makes more sense? So we work with partners, and if a large company tells us we want to do this specific product, that probably makes sense because they know what they want and what they can sell. When we choose our own product, it's been a mixed bag of successes and failures of what we can actually make and sell. And yeah, it's there's no simple answer, but again, it comes back to customer traction, understanding the market, and understanding what quality do you need to hit to reach a viable product. And you can frame that as, minimum viable product, or what is trendy at the moment, and what is bio-based. And I don't think there's a straight answer. I think there's a lot of trial and error in it, and you need really smart people on your innovation team to succeed with that.
That's where you need that connection with the market, isn't it, really?
Yeah.
Understanding the need. Is it the unmet need as well, or is it people talk about unmet need? Is it the customer saying, oh, I have a need, this is my business? Or is it more being a little bit more, the customer doesn't quite see it yet, but you come up with something unmet?
It's a mixture of that. It can be that we say we have an idea about something that we can bring to customer and say, how about this? How about this product that you're making? We'll make it bio-based. Do you want that? And sometimes they say no. I mean, sometimes we're just dreaming up this amazing opportunity, and when it comes to the real world, it's just not there because they already built the plant and they don't see any really huge benefit of making it greener. Maybe they think it's green enough. I can disagree with that, but they're the customer. So, and it's also legislation. Sometimes we see laws happening that will make products unviable in a couple of years' time, and companies are then interested in making better versions of them. That's one. And I mean, it's also about trends. So if you go back a few years, people were buying plastic straws without any doubts at all. Now people are not. So there's a lot of factors here, but yeah, I think it's simply about solving the real world problems. I would say that's where you really need to focus. And just because I have an idea that I think is good doesn't mean it is good. I need to go out and talk to lots of customers and understand what they think, and maybe I can persuade them, or maybe they persuade me and tell me I'm wrong.
No, great to get that perspective. And tell me, can you say anything more about the products? Like, you mentioned like the food, and you mentioned pharma. I'd love to understand a little bit more about the value that the product kind of has for the customer viewpoint, as it were.
Yeah, so many things that go into food are actually chemicals that have been manufactured. And if you manufacture them with ordinary chemical means, often you get byproducts in there that you are eating. And if you knew about it, you might not want to eat them, but they're legal. And if we then produce a better solution to that, the lawmaker can say, well, now you have a solution that is cheap enough. Now we're going to ban the old one. That happened with trans fat, for example. Trans fat is, so it's the same thing here. We're doing, it's still confidential who we're working with and exactly how it's going to, but it's a food oil process. So if you go to the store and buy extra virgin olive oil, that's just olive oil. Someone just pressed olives and got the oil out. But if you go to McDonald's or a fast food place and buy deep fried French fries, that is usually a transformed oil, a vegetable oil that has been processed. If you buy cookies, the same thing. There's a fat in there that is not butter, but mimics butter in its texture. So the enzymatic process we have transforms vegetable oils to having a better melting point, a better flavor profile, so it can be used for food. It's still vegetable oil, it's fine. It's just that the chemical process is now done enzymatically instead of chemically. And that is already done, but only 10% of the market for vegetable oil is that. So now we want to transform the entire one. It's going to take a bit of time, but we're well on our way.
And you mentioned earlier about kind of the challenges of, or maybe the next stage in terms of building scale, as it were. That's always been some of the buzz I hear over the years, CapEx and building your own plant and facility, working with CMOs. How does that work? So you build it in your lab, and where have you got to from a viewpoint of scaling up the enzyme, for instance?
So, yeah, and I mean, that's a great question, and it's very important to get it right. So we're lucky now that we have been able to outsource all the manufacturing. So from the lab, we analyze what specifications, what quality is needed in collaboration with the customer, and then we tech transfer to suppliers, so we don't have to build our own plant to produce that very product. And that's more complicated than it sounds. It takes a lot of time, and making something in 10 grams is not the same thing as making 10 tons. So that's been challenging. I feel that we are succeeding in that aspect now. So at a point in time in the future, I don't know when it makes business sense to take that manufacturing on ourselves, then we will. But at this point, I don't see any need for it. I'm very happy to have suppliers and de-risking the whole scale-up operation in that way, essentially, despite the fact that it takes time, and working with partners is of course something that is not always easy for purely technical reasons.
Is it a real challenge finding a real reliable, safe go-to partner that is going to be with you on the journey? And has it changed much post-COVID? Because I always fermentation capability limitations. Yeah,
it's more difficult to identify them than you might think, because it's, what scale are they able to produce at? What are they used to producing? Can they make the necessary adaptations to their manufacturing plant to accommodate our stuff, which is not heavy metals, not there's a new framework that needed. Can it be food graded? Can it be kosher? Can we adhere to the EU regulations, the US regulations, all these aspects, and at that specific scale that we need? So even though you will find lots of suppliers potentially fitting your need, there will not be that many usually that actually do. So you need to do that homework before, of course. And then you need to have a bunch of alternatives, maybe for different geographies, for different needs. So again, at some point, and this is just for the catalyst, this is just for the immobilized enzyme. If you're talking about making an end product, that's building an entire manufacturing plant, and we're not doing that right now.
Your future, just correct me, because you may have said your future is to deliver the enzyme, right? Or are you seeing that a little bit broader in terms of?
I'm seeing it broader. So the chemical industry, the players in the industry are typically served by three things, if you want to generalize it. One is catalysts. So a company will buy a catalyst from another company and use it in their own manufacturing process if they have the capability of devising that manufacturing process. If they don't, they will buy the second thing, which is a ready-made process, and they will license that from somebody who made that process, for example, Johnson Matthey, companies like that. And then you have the ones that you might think about is when you drive past a chemical plant. If you drive past Ludwigshafen in Germany, you see this enormous chemical plant that's making the end product. So, and those are the three things: so catalyst, processes, and end products. So EnginZyme has the luxury of operating in those three ways and be a partner to the industry that they're accustomed to. So we can sell the catalyst, but then that requires a lot from the customer. They need to know how to use it and to devise that process. And this is a new kind of catalyst, and we're specialists in making that. So that's why we also do the full manufacturing process that we can then license out. So we'll have a complete commercial plant design and tech transfer that to someone else's plant. And then when we have enough money and it makes business sense, we can actually build a plant and produce the end product as well.
Right. So that's the dream and the goal, you think?
And it's based on, there's no such thing as a one size fits all here. Different players buy different things depending on their capabilities. So if you're into cosmetics, if you're a cosmetics company, you might not have all the chemical engineering capabilities. So then you might want to buy or license a full process. Whereas if you are a large chemical company, you might say, we always make our own processes. We don't want to buy anything from you except the catalyst. So we supply that as well. So we try to be the partner that the industry needs. So we want them to see us as their go-to synbio partner. So we want to supply the three things they buy.
At what point does it make viable sense, though, to build an end product?
I think, to generalize, if capital is expensive, then it doesn't make sense. Basically, to give a simple answer. And right now, capital is quite expensive and it's risky. And on the other hand, if we have a product that is commercially viable and we can get good types of financing for building a plant at a reasonable size, then that makes sense. I don't see that right now.
Yeah. Okay, that's good to get that sense with things, as it were. So with regards to, I'm just thinking, about the industry. You think about the synbio industry, you think about the journey. Does it feel for you this world of industrial, biotech and enzymes and transforming the chemical industry? Are we where are we on the journey of this, as it were? I'm not sure if we're at the beginning, the middle, or we're really making progress on this.
Yeah, I think we're making progress. Too slow, but we are. I think there's a lot of will to make progress and people understand the need for it, but there's still nobody has sort of cracked the code on how to do this in a viable way. And the companies that right now are struggling, and without naming any, there are a few now that have seen difficulties in selling their product. Coming back to what I said about green premiums, I would say that that's a result of having a very good product, a great engineering solution, but not reaching, and this is a simplified argument, but nevertheless not reaching the cost of production necessary. So they're stuck with the niche of the market. Even though it's a huge product for the world, their product is a niche for a green premium section. And that has to be overcome. And if you're doing fermentation, essentially the classical way of seeing bioproduction being done, there are a few blockers for you to get good cost of production in general. It's just very difficult to get high product concentrations and getting a low cost product, and it's you're spending a lot of money to purify your product from a complicated mixture. These are technical details that are important here. So I don't see fermentation as a solution for everything in the biomanufacturing. I don't think there's any solution that is a solution, one size fits all for everything. You need to look at, where do you make more sense at the moment, and we need to keep developing technology. But once that happens, I'm an optimistic person. I think once people see, oh, there is a general aspect to this technology, it can be used for many things, then you will see like a catch-up effect, because now people suddenly trust these bio solutions. And then you will see hopefully enormously a lot of faster development than you see today. We need a few more key successes for the industry to just adopt what we're doing.
Are there any, when you look at the industry, are there any key successes that come to mind that you look at across the industry?
Yeah, I'm going to give you, I'm going to give you a boring answer. There's a process for PDO, which is a component to polymers that is actually fermented. So that's a biosolution that where it's a huge process, but it's not as huge as you would say for general plastic. But nevertheless, it's there, and it has outcompeted the incumbent chemical method. So why I bring that up is because I don't want to look at technical solutions that are really cool. There are so many of them where, oh, look, you can use this fantastic enzyme cascade, or look at this new technology where you make the cells do these fantastic things. Yeah, that's great, but real world examples, we have been making ethanol for forever with fermentation, and there are a few more examples where that works industrially. So we need to do that with more bio solutions and prove them as well. So there's a toolbox for the industry to say, okay, I want a chemical engineer at any company to feel that they're not doing their job unless they're testing the bio solutions. And that's not how it works today. They can stick with their incumbent methods, and they will not get fired for that. Whereas they might get fired if they spend a lot of money on a bio-based solution that fails. So there's this, and they're conservative, but they're rightfully conservative because we're talking about huge investments in huge factories, capex. So I understand their conservative nature.
Absolutely. And do you think, though, it's going to be as much about technology evolving that and getting better that will help solve some of the unit kind of economics?
Yeah, it's exactly that. And demonstrating that you get good costs, it works at scale. I'm just bombarding you with these first principle arguments here, but I think it comes down to that. It comes down to producing a product at the scale and cost that is required, and you need to demonstrate that can be done for more than a handful of products.
Yeah, absolutely. And so I suppose if you look out at 5-10 years, when you look at things, it's been coming up for 10 years. Well, how do you look at the company in terms of future-wise? And can you see yourself another 10 years as CEO? And how far out do you look with this?
So you know this expression that nobody got fired from buying from IBM? Yeah. I want people to say that about EnginZyme. Hey man, nobody got fired from buying technology from EnginZyme. That's where I want to take the company. That it's a natural go-to partner for chemical industry. And I love my job. You asked me how do I see myself as CEO? Yeah, I'll stay in my position for as long as it's making sense. I love my job, but I don't mind doing something else within EnginZyme if it makes sense, as long as I'm at the forefront of taking new technology to the market and greening the industry, whatever role that is. It's about the company now more than me. It's about fulfilling the vision, really.
Yeah, absolutely. Okay, no, it sounds exciting. But what does that look like, though, when you think about that, that statement about, no one getting fired from buying processes and enzymes from EnginZyme? Well, what kind of company do you want to build, as it were, in terms of, give me an idea of, those hopes and dreams of yours and what that
So
is.
now we're active in the food space, somewhat in the pharma space, and we're touching other verticals of the market as well. I see the company being supplying solutions throughout the chemical industry in various verticals, seeing us having the capability to deliver high quality catalyst to whoever has implemented our processes and or just wants to buy the catalyst for that matter, and being able to outperform the incumbents. Say, this is greener, it's faster, and it's cheaper. Yeah. And if that means that we have a bunch of plants, or it means that we have a very sophisticated lab. I don't know yet. It depends on, that's not the key thing. If we have, 10 plants or 100 plants, or that's not the key thing is having enough. I can transform it to CO2 equivalents. For every ton of food oil we convert, we save 340 kilos of CO2. So transform that number to the billions of tons of products the chemical industry produces. So I see us having a significant impact on the reduction of CO2 equivalents. That's that's how you can formulate. And of course, that is a a huge company with massive revenue and a lot of people.
Yeah, absolutely. Well, it looks like you're living your dream every day, Karim. That's what it looks like, from back in the lab and back from discovering and patenting technology to where you are now. It seems that you're living that dream and helping to make a difference and to decarbonize the world.
Absolutely. And I pinch my arm every time I walk into my office and lab, like, oh wow, this is really happening. And I remind myself of that when it comes down to the daily grind. There's always a bunch of jobs that are not that inspiring unless you remember why you're doing it. So it gives me a lot of purpose. And I feel very happy as well that the team has the same sentiment. People work hard, people do spend their lives working for EnginZyme, and they come to us with enormous amounts of competence from various parts of the world, and we expect them to work hard. And they all feel that the purpose of the company is a major driver in why they did that. We have people coming from California to Sweden and working here. So, and of course we pay less salaries and the weather isn't as good, but still they're here. I also believe in the diversity. The team is I think we're at 25 different countries in our team right now, and Sweden has a lot of good aspects to it as well. We have a longer vacations than most countries have. We have a good social framework, good work-life balance. All those things, of course, weigh in, but I think having a strong mission and purpose is what's the key driver, why people want to do it.
Yeah, absolutely. That's great, Karim. So thank you so much for coming on and sharing a little bit about your journey, and rooting for you guys and wishing you all the best for the future.
Great, Simon. Thank you so much for having me on your podcast. Thank you.
Pleasure.